So this video just try to introduce the spectrum of the ring and prove a theorem corresponding to the spectrum of R. Okay, so R is a commutative ring with identity. Okay, so spectrum of R as a set is just all the prime ideal of R. Okay, and the second is that we can give the topology of this spectrum of R. So give a topology of spec of R. It's called Zariski topology. Okay. So once we give a Zariski topology, then I need to specify the open set and closed set. Okay, or one of these. So I is ideal of ring. So I can the open set. Okay, so sorry, the closed set. So the closed set corresponding to I just all the prime ideal belong to spec of R such that I is the subset or the open basis. I write df basically is f does not belong to P and the P belong to spec of R. Okay, so this is the open set, this is the closed set, this is the closed set. Okay, so the theory is that spec of R is quasi-compact, or basically I mean just compact. So usually quasi-compact means that the topological space is non-Hausdorff but compact. Okay, and the usual, so actually quasi-compact just compact. Okay. So that means we need to prove that any open cover has a finite subcover. Okay, so key point is that okay, so we may assume the open set, the open cover is just basis, basis. So that means, simply speaking, is the spec of R is just covered by the dfi for some I in the for if all fi belongs to R. Okay, so this tell you that all. Okay, so there's no prime ideal. There's no prime ideal containing all fi. This is just the definition of this df. Okay, so which tell you that if you create a linear combination of all these fi, then you will get the spec of R. So we tell you that 1 is the summation of vi fi. And since we are working ideal, so this is just finite sum. Okay, so if you go back, you go to the derivation, go back, then you can prove that all these fi generate the spec of R. Okay, so this is finite sum, so I call it J, finite. So we can prove that the spec of R is just finite. Okay, and df of J. Okay, so this proves that the spectrum of R is quasi-compact. Spectrum of R is quasi-compact. Okay, so this is our very short introduction to prove this spectrum of R, and I will see you guys in the next video.